Hey, what is up everybody? Today I'm going to show you a really useful tool in trigonometry that allows you to find any angle inside the circle if you're given the arc length, which is the yellow part of the circumference here, and if you're also given the radius. So to find the angle, just use this formula and take the arc length divided by the radius, and that is going to give you the angle in radians. So we're given the circle with the arc length of 8 centimeters and the radius is 5 centimeters. And it's asking us to find the angle theta inside the circle. So using the formula, we know that theta is equal to the arc length, which is 8, divided by the radius, which is 5. And so the answer is just basically 8 divided by 5 radians. Now, some people prefer to work with angles in degrees. So is it possible to convert from radians into degrees? Well, absolutely yes. And the way to do it is, well, first of all, I'm going to give myself some space. So instead of writing radians, I'm going to write RAD, and you know that stands for radians. And now I'm going to convert from radians into degrees. So the way to do it is you take this ratio, you multiply it by 180 degrees over pi radians. Okay, and if you don't know where this ratio comes from, I will explain in a moment. But the reason why we do this is because we want to cancel out the radian unit and obtain the degree unit. And so we can also cancel out the 5 from the 180, and that gives us 36. So this multiplied by this gives us 8 times 36 over pi degrees. And if you put this into a calculator, it gives you approximately 91.67 degrees, or you can also write it with the circle on top, which stands for degrees. And so I actually made a video on how to convert between radians and degrees, and also from degrees to radians, and I will link it down in the description below. So check it out if you want to get a review on how to do the conversion. And how about this one? So we're given the circle, we know that the radius is 10 centimeters, and we also know that the angle is pi radians. And how do we know that this is in radians? Well, because the angle here does not have the little circle on top, which indicates that the angle is in degrees. So that's why we know that this angle is pi radians. And the question asks us to find the arc length, which is this yellow section of the circumference, and it is pretty easy. So we use the formula. To find the arc length, we basically multiply both sides by the radius, and that's gonna leave out the a on one side of the equation, which is a is equal to the angle multiplied by the radius. And so since the angle is pi radians, we put pi in here, and then the radius is 10 centimeters, and so it's basically pi times 10, which is about 31.4 centimeters. Okay, let's do a few more. In this diagram, the arc length covers the entire circle, and so we know that the arc length is equal to the circumference. And we also know that the radius is r, but we don't know how long it is. And so can we still find the angle theta, which is inside the circle? The answer is yes. And so using the formula, we take a divided by r, and since a is the circumference, which is 2 pi r, then we just substitute it in there. And so the next step is to cancel out the r, or the radius, and we are left with 2 pi radians. So 2 pi radians is approximately 6.283. So what does this tell us? Well, it tells us that whenever the arc length is equal to the circumference, or when the arc length covers the entire circle, then the angle in here is going to be approximately 6.2 radians. So you might know that 360 degrees is the angle that covers the entire circle. But in the last problem, we found out that 2 pi radians is also the angle that covers the entire circle. So this means that these two are the same. And so because 360 degrees is the same thing as 2 pi radians, we can divide both sides by 2, and that gives us 180 degrees is equal to pi radians. And that's where we get the numbers from. And these numbers are extremely useful when we convert from radians to degrees, which is something that we did a few problems ago. Let's do one last problem. A car traveled 965 kilometers in a straight line. If the moon's diameter is 3,476 kilometers, what percentage of the moon has the car traveled? And so our diagram looks something like this. So the car is traveling around the moon like this, even though it's going in a straight line, the planet is round. So that's why it's going in this kind of direction. So the car went around 965 kilometers, and the diameter of the moon is 3,476 kilometers. And it's asking us to find the percentage of how much the car has traveled. So the first thing we need to do is find the angle. All right, so the arc length is 965 kilometers. The radius is half the diameter. So that's going to be 3,476 kilometers divided by 2, which is 1,738 kilometers. And so using the formula, we take A divided by R, which is 0.555 radians. So we got the angle in radians, and that's great. But the problem is asking us to find the percentage of how much the car has traveled around the moon. And so to do that, you take 0.555 radians and you divide it by the entire angle, which is 2 pi radians. Okay, and when you multiply it by 100%, you're basically converting the number into a percent. And that gives us 8.8% of the moon. And so the car has traveled around 8.8% of the moon. And so I would like you to try this on your own. Okay, so the angle is 160 degrees. The arc length is 8 centimeters. Your job is to find the radius using the formula. And so one tip is, as you can see here, the angle is in degrees. Okay, the formula works when the angle is in radians. So you must convert this angle from degrees to radians first. And so that is basically it for today. I hope you guys have learned something new. If you haven't already, please hit the subscribe button and comment down if you have any questions. I'll see you guys next time.